welcome to our Facebook Live. Thank you for joining us. We're at the Airbus Mock-Up Centre in Toulouse, and actually we're in not a real aircraft, but we are in a real cabin. And we know lots of you are going to be taking flights fairly shortly, so we're here today to talk about cabin air and cabin air flow. Please do send in your questions during our live, and we'll try and accommodate as many of you as possible. My name is Justin Debon, and I'm joined by Jean-Brice Dumont, who's the chef of Airbus Engineering in Toulouse. He's the chief. We've already received many questions which we're going to pose to Jean-Brice, and we're happy to take more, as I say again, if you pose your questions during the live. So, turning to you, Jean-Brice, first of all, can you explain simply how does cabin air flow inside a cabin?
Yes, thank you, Justin. I'll start by saying that we're here in an A350, which is our latest long-range aircraft, and we're in an economy class, which is representative for what we want to say. Now, what about the air in the cabin? What you need to know is that the aircraft flies high in a quite hostile environment. The air outside is very cold, below minus 50 degrees Celsius. Oxygen is rare. So it's our duty to take a particular care of the air in the cabin, obviously, for the safety and for the health of the passengers. So we must ensure that the air has the right pressure, the right temperature, and that it's clean. And it's very, very important. And this has been the case since the beginning in aviation for the comfort of the passengers and for their safety. And we've been caring for health for a couple of decades. Now, how is it working? The air that you have around you is made of two parts, in a way. Half of it is thrown out of the aircraft and replaced by fresh air from outside, which is heated. And the other half is recirculated, as we say, like when in your car you press on the famous button with this circular arrow. And it's recirculated going through filters, which are named HEPA. And these filters are super efficient filters of a hospital type, I would say. Why do I say super efficient? Because they are designed to capture particulates of about any kind in the very small particulates type, like viruses, like bacteria, and for typically a particulate like the COVID, they capture more than 99.9% of the particulate, which means at the end that the air that comes back to you is clean from viruses, microbes, and that's very important to know it. The second part is that the air is blown vertically, in a way. It's blown downwards from up there to the floor, and there is no longitudinal flow of the air. It doesn't go from the first row to the last ones or the other way around. The air is really conditioned per row, I would say. And the third thing is that this system is quite powerful. It blows the air rather powerfully. So you can consider that the air around you in a cabin is renewed 2 to 3 minutes. That means every 2 to 3 minutes you've got fresh air, or said in other words, 20 to 30 times per hour, the air around you is fresh, is renewed.
You said something very interesting, that Airbus has been working on making flying safe forever, basically, and that it's not just because of COVID that we have this clean air. We've always strived to have clean air. Can you explain that?
Yes, of course. First, we must ensure that the air has the right pressure and temperature, and this is the case since the aircraft fly at high altitude, since the beginning of modern commercial aviation. And about health and the fact that we could have propagation of particulates like viruses, microbes, it has been our duty forever to ensure that the aircraft is not an area where people can easily contaminate each other and when contaminated particulates can go around the aircraft. And typically we've had other pandemic before. I mean, at the time of SARS we had to pay a very particular attention on it, but it was even before SARS. It's our duty to take care of the passengers of our aircraft, like we have to take care of the safety of the aircraft. So very clearly, we've been on that for decades, and these filters we are talking about have been installed on our aircraft for 20, 30 years. All our aircraft are equipped.
That's very, very clear. Jean-Brice, could you demonstrate to us what it means when you say the air flows vertically rather than horizontally?
Yes, I think it's it's better to explain it with my hands. You've got here on the floor, or just here, you've got vents. So the air is coming from here, it's flown down, it goes down, and then it's evacuated by the bottom here at the floor level. So you really see that you've got this airflow coming here, and it doesn't flow backwards and it doesn't flow forward. It's really a vertical flow of the air downwards.
And is this along the entire length of the aircraft or just in parts of the aircraft?
And it's exactly along the entire length of the aircraft, from the first to the last row. Behind there, you've got big pipes that carry the air and distribute it along the aircraft, and you've got the same pipes underneath, which means at the end, if I summarize, that each row has its private air conditioning.
We have one question, a live question, from a viewer. How is it possible to get 100% fresh air at high altitude?
Well, getting 100% fresh air would mean changing the mix, but I would say that the air that we have in the cabin recirculated is much purer than anything else, and having the pure fresh air in high altitude wouldn't really make sense. These filters are precisely designed for that, and we have measured in the past that the aircraft in altitude has much purer air by measuring microbes, bacteria, than when it was on ground. So it's a kind of a live measured demonstration that the system as it works is the right mix.
And can you explain why it's important that the movement is vertical and not horizontal?
I think what we need to prevent is indeed that if you consider somebody is sick, I'm not even talking about COVID, if you consider somebody is sick, that the ability of that person to potentially contaminate neighbors is very limited. So that's why, on the one hand, the air doesn't move forward and backward, so that the circulation of air around a person is limited to that person's row. And on the other hand, that the air is renewed powerfully every 2 to 3 minutes, so that even though that person may have a contamination of the air around him or her, that air is evacuated and is renewed.
And every 2 to 3 minutes is very quick. One of the questions we had is, can it be done even quicker, and is it up to the airlines how quickly it's done?
I think when we say 2 to 3 minutes, in fact we give a range, which is a range which depends on the size of the aircraft or on the power setting of the ventilation, like in your car, where you can adjust the power. So what the crew can do is turn the power setting of the ventilation to high, which then forces a more powerful ventilation and a renewal time which is shorter. But you have to bear in mind that it's 2 to 3 minutes, and at the end it's better potentially to have it in high, but it's still a very, very fast renewal.
And you also mentioned HEPA filters, same sorts of filters that they use in hospitals. Do they themselves need some maintenance throughout their operational life?
Yeah, I think all filters in any filtration system need maintenance, need renewal. As far as the HEPA filters are concerned, it's a quite loose maintenance. We have time until maintenance and time until removal. But it is not much different to the filters of air conditioning systems in other areas. Typically in hospitals where they have the same kind of filter, the slight difference is the renewal rate. We have the same filters, but we renew the air much faster.
Another question we had is the air is changed during flight every 2 to 3 minutes. What about when the aircraft is waiting on the ground for loading passengers? What about then?
When the aircraft is waiting on the ground, the crew has the choice. The ventilation could be off, and many of you as passengers have heard this noise when the ventilation is started. Everybody is having flown a bit is familiar with that noise. So I think the fundamental question for the airlines is to switch it on early enough before the passengers come into the aircraft, while until now, sometimes for noise reasons, they waited a bit until they switched it on. So I think our recommendation will be and we are in discussion with the airlines, to switch it on before boarding, so that the air has already been renewed a couple of times when the passengers enter. So in a way, they already enter a clean area.
Well, we're getting some more questions which are interesting, and this one is another live one. If you change the filters, like the HEPA filters, is the air of a new HEPA filter cleaner than one that's been slightly used?
No, I think the HEPA filters are designed to be efficient until replacement. I mean, like anything we design on our aircraft, the policy of replacement of any part of an aircraft is that the part must be effective until replacement. And generally, we apply safety factors. That means, I would give you an illustration. If we consider the efficiency is 18 months, we will ask for replacement at 12. For many of our safety policy in our aircraft, we always apply safety factors to be sure that you're well protected from the time when you would lose efficiency.
And another question that's just come in. When people move around the cabin, like boarding, disembarking, or else even during flight, just moving around, does this disturb the vertical movement of air, or should people not move around so much?
No, I think it does not disturb the flow, but we must always pay a particular attention on the movements. I think the movement of people is an area of risk, but it is not limited to the aircraft. It's the movement of the people in the airport. It's the movement in the people in many areas. So here, there's indeed a question when people move in the aircraft of having the right measures, the right personal behaviors, ensuring that hands are clean, that when you're seated next to each other and all along the flight you wear masks, even more when you move. I think that there must be particular attention and particular set of measures depending on the situation. When you're seated, when you're moving, when you're boarding, when you're on the airport. And finally, it's just an extension of what you have to do from the morning out of your bed to the evening.
One thing that I've heard people say is that, and we've had some questions on it, is that the air might be really pure on an aircraft and it's changed every 2 to 3 minutes, and you've got HEPA filters and it's very, very clean, just as it is in an operating theatre. But the density of people in an aircraft makes it all the more important that this is the case. Why? Can you explain why people shouldn't be worried about the density?
I think that's potentially the most important question. People will wonder, why can we say that you can sit in an aircraft like this, which is full? Aren't we taking the risks? And I think here it's about the overall set of measures we are taking. It starts by minimizing the risk of people entering the aircraft being contaminated. This risk will never be zero. Doesn't exist in life, but taking temperature checks at the airport, having people fill in declarations, having apps, tracing apps that can tell what people have done, a set of measures that ensure that the persons entering the aircraft have a low risk to be contaminated is the first thing. And then it's about the behaviors on board. It's about cleaning hands when you enter. It's about wearing a mask during the whole flight, particularly when you're seated with a neighbor. But the wearing the mask is just a normal posture. And when you've piloted that, and considering that the air around you is renewed every 2 to 3 minutes, which means that in a way, I wouldn't say you're changing neighbor every 2 to 3 minutes, but the point is really that there's a permanent, like a sliding belt below you that is moving things around. The fact that you're seated for a couple of hours next to somebody doesn't represent a higher risk than being in another area where you will be close to people for a given period of time, like shops. But here the air doesn't move much.
And another question we've just got in is to do with the filtration of the aircraft and the cleanliness of the cabin. Is this standard equipment, or is it something that's new?
No, but this filtration of the cabin is a real standard. Some people believe we are reacting to the situation. Of course we're reacting, we're always trying to explain what we are doing, but we've had these filters for decades on our aircraft. The whole Airbus fleet is equipped, and I wouldn't stand for the other aircraft manufacturers. It is not my role, but in a way I can say it's an industry standard. So yeah, the HEPA filters, which have a real duty to ensure that there is no propagation of particles like viruses or bacteria in an aircraft, they are a standard in the aerospace, in the commercial aviation.
Thank you for sending in your questions, and please do send some more questions whilst we go on with this discussion with Jean-Brice. Jean-Brice, let's sit down and see what it's like to what it's going to be like to fly in the near future, at least, and let's discuss what I mean. So this is how we would be flying in the foreseeable future. Can you explain why is it important to wear masks? I mean, what difference does the mask make?
But I think the mask in an aircraft is not different to the mask in dense environments where in most countries people are recommended to wear masks. You wear a mask because it's your duty. It's your duty to not to take the risk to potentially contaminate others. If you look at some continents where when people are sick, they wear a mask. It's a kind of a personal responsibility they take for their society, not to be the person contaminating others. And then if you consider anyhow you're sick, you've got a flu, the day you cough or you sneeze, the mask is the first barrier. That's very obvious. And then you've seen everywhere this recommendation to sneeze or cough in your elbow, which is a way to minimize any kind of flow that would get out of the mask, which is already a strong barrier. And after that, you still have to think that the air around you is flowing down, and that being renewed every 2 to 3 minutes, within a minute, everything has vanished. So the ability the likelihood to contaminate your neighbor is very low. I mean, you're facing forward on top, and even when you look at each other and I'm talking to you like this, it would go in that direction. So I really consider that the risk of contamination cross-seat is very limited, and much more limited than in other environments.
And just one question in, we're sitting in quite close together, and there are lots of things that we can touch. What about contaminated surfaces?
Yeah, that's a very good question. I think it goes during a flight. It goes by the way people behave. Again, it's about having clean hands, having wipes available when you need to clean your environment. It's a lot around the way the aircraft is cleaned between flights. So I think it's a very important point, and we have not talked about it. But the cleaning of the aircraft between flights is a point of attention to ensure that the one that's going to be seated after me on this seat runs no risk to be contaminated by the fact that I would have potentially been a COVID person.
Thank you very much, Jean-Brice. Let's get out of our seats, and I'd like to ask you a question. Like, we've talked about what the manufacturers can do, and what passengers can do during traveling. Could you give us some insight as to some of the other measures that we could be working on, like, for example, surfaces, or what some of the other things that Airbus is doing to try and make cabins even safer than they already are?
We are actively working with the airlines on the cabin cleanliness, and I think it's a lot about what happens during the flights, but the inter-flight, the turnaround, as we name it, the time when the aircraft is on ground between two flights is key. So the ability, the agents, the cleaning agents, the airline will use to clean the aircraft between two flights is a real important point. There are typically, just to give you an example, there are typically agents which are starting to be used by some airlines, which remain on the surfaces for 5 days. So for 5 days you can consider that it's virus-free, and it's a very, very good thing. If you add that to normal cleaning between two flights, you've got a quite powerful protection against viruses, and you can ensure that the aircraft, when the next passenger will board, is clean enough. There are other means like UV. One reads a lot about UVC, which is one type of ultraviolet lamp that is deemed killing viruses, and you can think of devices to clean the whole cabin by UV. And there are many other means we are working on, particularly around cabin cleanliness. But this is about the seats. There are similar considerations about the overhead bins, similar considerations about the toilets. All of this is being thought through together with the airlines, so that any stage of the flight and around the flight, at the airport, while queuing, boarding, security, and at the airport after the flight, all of this is considered, with always the right mix of measures to ensure the best protection of the passengers.
And Jean-Brice, we've had another question, and this is a very topical one, as flights start to recommence after a break of several months. How important is it to leave the middle seat empty?
We do consider, with what I have said on the ventilation of our aircraft, which is powerful, flowing downwards and renewing the air every 2 to 3 minutes, we do consider that letting the middle seat free makes no real sense and has no added value in terms of protecting you. You're on a seat like this. When you're sneezing, when you're talking, most of the droplets, if you imagining you wear no mask, which is not the case, would go forward or diagonal. So it's more the back of the seat in front of you which is hit by these droplets, and therefore a cleaning question rather than your neighbor. So I think the question of the empty middle seat is not the right question. The question is more a question of cleanliness and individual postures.
Thank you very much, Jean-Brice. That's a fascinating explanation, and thank you so much for your time to explain about cabin airflow. I hope our viewers have enjoyed this, and thank you for posing your questions. We had some very good questions for you, and we asked them live. Before we end this transmission, I would just like to point out that on our social media channels we do have a video that explains diagrammatically what we've been discussing today, and time flies, so we have to come to an end, and we hope you'll be flying soon. And to our viewers, thank you so much for joining us, and enjoy your next flight.
Thank you.